today's lesson is about function notation, function operations. A function is what we've been working with. But instead of having y equals x, something x, you're going to have f of x, g of x, h of x. You're going to have it in function notation. We have done stuff with function notation in here before. And I will say function notation is much, much more common. The higher you proceed in your mathematics, the more it's a function notation. I like function notation. It's easy to evaluate. It's easy to use, much easier than y equals. Okay. When we say it, we say f of x. We say g of x. It's a function f. F is my function. Happens to be a function of that particular variable. If we've defined f as a particular function, and we want to evaluate it, we say f of whatever we're evaluating at. Whatever I replace x with in the parentheses is what I replace x with in the function. And I can do anything in there. Now, composite functions are compound functions. One function of another. That is what a composite function is. So, and we will get to composite functions as examples specifically, but a composite function is where I'm taking a function of a function. So, for example, if I look at here, I have f and g are two of my functions. A composite function would be where I'm taking f of g of x, which means that I take whatever g of x is and stick it inside of f. That is a function inside of a function. That's what composite functions are. And you can put them inside each other, lots of them, and we will be doing that. There is other notation for this that I don't believe we use here, but I want to show it anyways. Okay. Those mean the same thing, and that's not an O, that's a little dot with an open circle. It's not actually a zero. It's kind of like, you put degrees on angles. It's kind of like that little circle only between the two. And that means f composed of g. That means the same thing. It's the second function inside the first one. And I'll show examples, and having examples will help you understand that much better than seeing it written here, I'm sure. Okay, but that's what a composite function is. I'm taking something, sticking it inside something else. So for our example problems, we will define the function f as 3x plus 2, g as 2x squared, h as negative x minus 4. Those are our definitions, and all the examples that we're going to do together will essentially use those ones, and I'll have them on every page. So if I want to find f of 2, I took the x that's here and replaced it with 2. That means I take the x here, replace it with 2. 3 times 2 plus 2. That's one of the nice things about function notation. If I want to evaluate a different number, I just plug it in, evaluate a different thing. 3 times 2 is 6, plus 2 gives me 8. F of 2 is 8. If f of x is 3x plus 2, f of 2 is 8. If I want to do h of negative 1, well, h is negative x minus 4. Took x, replaced it with negative 1, so I have negative 1 minus 4. Whatever x is, I replace it with negative 1 and evaluate. Negative 1, that's 1 minus 4, get negative 3. And if I want to do g of negative 3, I do the same thing again. I take g of x, it's 2x squared, so I take x, replace it with negative 3. 2 times negative 3 squared. Negative 3 squared is 9, times 2 is 18. Do not screw up your order of operations. I guarantee if I put that on the test, I will have a number of you tell me that that is 36. But it's not 36. It's 18. You take the number to the power first, then times 2. Not 2 times the number, then the power. Order of operations. Exponents first. Remember that. Okay. Same functions. This is a composite function. This is an example of a composite function. g of h of 3. What I need to do to be able to find g of h of 3 is I need to first find h of 3. I have to figure out what this is, and I put that into g. So off to the side, I go, okay, what's h of 3? Put in 3 for negative, put in 3 for x. So it's negative 3 minus 4 is negative 7. H of 3 is negative 7. Do you see where I got negative 7 from? Okay. So if I want to find g of h of 3, that really means I'm looking for g of negative 7. H of 3 is negative 7. I put in negative 7 for h of 3. Now I evaluate this. So that's 2 times negative 7 squared, which is 98. 7 squared is 49 times 2 is 98. Same thing on the next one. I want to find f of g of negative 2. My innermost function is g of negative 2. I need to figure out g of negative 2. G of negative 2 is 2 times negative 2 squared, which is 4 times 2 is 8. G of negative 2 is 8. So that means if I'm finding g of negative, f of g of negative 2, that means I'm really finding f of 8, which is 3 times 8 plus 2, which is 3 times 8 is 24 plus 2, 26. Okay. How many functions do I actually have going on in the last example? 3. I've got 3. I've got h of g of f. Always start with the inside one first. What's my innermost function? F. I want to find f of negative 1 first. I have to do this. I have to do f of negative 1. So f of negative 1 is 3 times negative 1. 3, right, 3 plus 2 is negative 1. Oh, that's nice. F of negative 1 is negative 1. Yay, it makes my life easy. This is a simple one. So if I'm finding h of g of f of negative 1, I'm really finding h of g of negative 1 because f of negative 1 is negative 1. Now I need to figure out what g of negative 1 is. Okay, g of negative 1. That's 2 times negative 1 squared, which is 2. That's nice and easy. So if I'm finding h of g of f of negative 1, that really means I'm finding h of g of negative 1 because f of negative 1 is negative 1, which means I'm really finding h of 2. So that's negative 2 minus 4, which is negative 6. Okay. You with me so far? Have I lost you yet? You have a question? Are you good? Okay. Because now it gets a little ugly. Same idea, though. Same idea. It's really, this is, I do this all the time. I use function notation in a lot of my classes. The higher up you go, you're going to see it. This looks really bad, but it really isn't as bad as it looks. Okay. Same f, g, and h. If I have f plus h of x, what that really means I'm doing is f of x plus h of x. Okay, that's not that bad, is it? It looks, oh my God, I'm taking, no, I just take f of x and h of x and add them together. Okay, that means I take 3x plus 2 and add to that negative x minus 4. 3 minus, so I get 2x minus 2. That's what f plus h of x is. And I actually prefer doing the composite. I actually prefer combining them in terms of x rather than in terms of numbers. I much prefer this one to this one. But the process is still the same. What this means is that I have h of 5 plus g of 5. That's all that means. So instead of x, I've got 5. So I want to know what h of 5 is. Well, h of 5 means I put 5 in for x. So that means I have negative 5 minus 4 plus, put 5 into g. 2 times 5 squared. Okay, negative 5 plus 4 is negative 9. 2 times 5 squared is 50, which means that I get 41. Good so far. Listen, I work with it all the time. I love function notation. It's one of those things, to me, it's easier, it's better, it's more versatile than regular equations. F minus g means that I have f of x minus g of x, which means that I have 3x plus 2 minus 2x squared. And there's not really anything I can do to that. If I really wanted to, I could rearrange and put it in standard form. But who cares? It's not that big a deal. Leave it like it is. Okay. This is a little trickier, but it's still the same idea. This is g times h. This is g of x times h of x. So I take g of x, 2x squared, and I multiply that times h of x. Negative x minus 4. Negative 2x cubed minus 8x squared. That's all that is. F minus h. F of 2 minus h of 2, which is 3 times 2 plus 2 minus negative 2 minus 4. 3 times 2 is 6 plus 2, this is 8 minus negative 6, so I get 14. If I did my arithmetic correctly. That's not always a guarantee. Okay. F times g of x, f of x times g of x, which is 3x plus 2 times 2x squared. Distribute the 2x squared. Times 2, 6x cubed plus 4x squared. How are we doing? We're doing good? Okay, same F, G, and H. Slightly more complicated, but still really the same thing. H over G of X is H of X over G of X, which means that I have negative X minus 4 over 2X squared. Ooh. Here's one that really throws students off. 3 times f of x plus 2 times g of x. Well, we know what f of x is. F of x is 3x plus 2. So 3 times f of x is 3 times 3x plus 2. We know what g of x is. G of x is 2x squared. So 2g of x is 2 times 2x squared. Distribute, combine up like terms if there are any. You get 9x plus 6 plus 4x squared. That's it. Not that difficult, is it? It really isn't. It's just manipulation. Evaluation and manipulation. That's all this is. Algebraic manipulation, algebraic evaluation. And these are important skills to have. Being able to manipulate things algebraically is a big deal. Okay? It makes it work later on either more difficult or more hard. If you can do this, it makes it a lot easier if you can manipulate variables. You can manipulate equations, combine up like terms, things like that. A simple skill like this really does make a difference in the long run. Okay. F of h of negative 2 is f of negative 2 over h of negative 2. F is 3x minus 2, so that's 3 times negative 2 plus 2. H is negative x, so I have negative 2 minus 4. 3 times negative 2 is negative 6 plus 2. Gives me negative 4. Negative 2 is 2. 2 minus 4 is negative 2. Negative 4 over negative 2 is 2. Simplifies out. Nice and easy. Questions? Okay. Composite functions. F composed, see the little circle thing? This is what I was talking about. It's not really a dot, it's not an O, it's a little goofy little symbol. This is a composite function. This is F composed of G. We've actually done F composed of G. This is F of G of X. That's what that means. It's F of, it's the first function of the second function. The second function is inside. F composed of G of X. That means I take G of X, stick it into F of X. This means that I'm really doing F of 2x squared. G of X is 2x squared. I'm taking F of 2x squared. I took the X in F, replaced it with 2x squared. So I take the X in here, replace it with 2x squared. 3 times 2x squared plus 2. I took G and stuck it inside F. G is 2x squared. I stuck it inside of F. 3x plus 2. Simplify. 6x squared plus 2. The trick to this is understanding which one goes inside the other. That's the trick to getting this one right. Okay, so I want G composed of H, which means that I have G of H. Which means that I'm taking G of negative x minus 4. Oh, poop. That's not that bad. What is G? G is 2 times whatever x is squared. So G of x minus negative x minus 4 is 2 times negative x minus 4 squared. Take what h is, stick it inside whatever g is. Okay. Squaring. It's not x squared plus 4 squared. It's not x squared minus 4 squared. It's negative x minus 4 times negative x minus 4. Or you can use the shortcut for squaring. Square the first term. If I take negative x and square it, I get positive x squared, because a negative times a negative is a positive. Positive x squared. Multiply the two terms. Negative 4 times negative x is positive 4x. Double it to get the middle term. Plus 8x. And then square the last term. Negative 4 squared is positive 16. And that's only the squaring part. I still have to multiply everything times 2. 2x squared plus 16x plus 32. Okay. And the last one here, f composed of f of 2. It's actually h composed of f of 2 is h of f of 2. So I have to figure out what f of 2 is. F of 2 is 3 times 2 plus 2, which is 8, because we found f of 2 several times already. So that means this is actually h of 8. Because f of 2 is 8. Plug in 8 into h. Negative 8 minus 4, negative 12. And if you have functions, you can stick any function inside another function. You can even stick a function inside itself. You can find f composed of f. Take 3x plus 2, stick it into 3x plus 2. No big deal. I've done it. Okay. Your turn. Work on these. Do these, and then we'll do the next group together. Then we'll go to the next page and do them. Remember, the F, G, and H have changed. Make note of that. Oops. Do I pause? Okay, let's go over these. Do the first few. So g of negative 5, g of x is 3x squared. So that's 3 times negative 5 squared, which is 75. H of 3, that's negative 3 plus 5, which is 2. F of v, it doesn't matter what I put in there. I took x, replaced it with v, so I take x, replace it with v. This is 2v minus 1. That's it. You can stick anything in there. You can evaluate anything. H of w, same thing. Negative w plus 5. Okay. F of h of negative 2, I find h of negative 2. H of negative 2 is negative 2 plus 5, which is 7. I almost put 8. That's 7. So this is really f of 7. Which is 2 times 7 minus 1, which is 13. G plus f of 1 is g of 1 plus f of 1, which is 3 times 1 squared plus 2 times 1 minus 1. 3 times 1 squared is 3, plus 2 minus 1. 3 plus 2 is 5 minus 1. I get 4. Questions on those first 6? Yes?
Did you say 5 minus 1 on the last one? Yeah, 3 plus 1.
Where?
On the last one you did.
This one?
Yeah.
3 plus 2 minus 1. Which is, yeah. Which is 2, which is, well, okay, if I do this in here, what do I get? I get plus 1. 3 plus 1, I still get 4, right?
Yeah.
Still got 4. Because it's all addition, once I get to that point, it's just addition, so it doesn't matter having the parentheses or not having the parentheses. But if you do inside here first and do 3 plus that, you'll still get 4. Okay. So that's fine as far as that goes. And I asked because I got to move this up. And fortunately, that's why I wrote these down over here on the board, because they're no longer on the screen in front of me. So f minus h of x is f of x minus h of x, which is 2x minus 1 minus negative x plus 5. So distribute the negative, makes it easy. 2x plus x, 3x, negative 1, negative 5, minus 6. F minus h of negative 1 is f of negative 1 minus h of negative 1. So that's 2 times negative 1 minus 1 minus negative 1 plus 5. 2 times negative 1 minus 1, so that's negative 3 minus, and this becomes 6. Negative 3 minus 6, negative 9. Okay. And the next one, a little more difficult, but still not terribly taxing. That's h of x times f of x, which is negative x plus 5 times 2x minus 1. Okay, no shortcut for this. You got to FOIL it out. Negative x times 2x, negative 2x squared. Negative x times negative 1 is plus x. 5 times 2x is 10x. 5 times negative 1, negative 5. Combine out my like terms. Negative 2x squared plus 11x minus 5. Yes?
So the f minus h of x and f minus h of negative 1.
You could, because you know what f minus h is, you could, f minus h of x is 3x minus 1. You could take this and just take this negative 1 and put it in here, and you get 3 times negative 1 minus 6, which is what? Negative 9. So you could do that. Is that where you were headed?
No.
Oh, okay.
I got 3x plus 4, and then I got negative 3 plus 6 plus 3. I don't know what I did wrong.
Well, f is 2x. You put negative 1 in here. So it gives you negative 2 minus 1 gives you negative 3.
Yeah.
And then you put negative 1 in here for x. Negative 1 is 1 plus 5 gives you 6. So negative 3 minus 6, negative 9. I don't know. I can take a look at what you did and see if we can figure it out later. Yes?
Don't you distribute the negative to the 5 as well, so it's negative 5?
No. I simplified what was inside first. This changes because it's negative 1. Because I put negative 1 in for x, so it's negative 1. That's where the double plus comes from. Do you see that? Okay. Okay, do those 6. Everybody has this one done too, so let's do this. Negative 2 times f times minus 3 times h. So it's negative 2 times 2x minus 1 minus 3 times negative x plus 5. So negative 4x plus 2 plus 3x minus 15, negative x minus 13. G of x over h of x, g of x over h of x, so that's 3x squared over negative x plus 5, right, 3x squared, yeah. Can't do anything to that, so I'll leave it alone. F of g of 4 is f of 4 over g of 4, so that's 2 times 4 minus 1 over 3 times 4 squared. So that's 7 over 4 squared, 16. 3 times 16 is 48, I believe. F composed of h of x is f of h of x, which means I'm taking f of negative x plus 5, which I'm taking 3 times negative x plus 5 and, 2x minus 1. So I do 2 times negative x. So I get negative 2x. 2 times 5 is 10. Minus 1 gives me plus 9. And I'm going to slide that up. Yeah, it's a 2, not a 3 here. 2. 2x plus 10 minus 1, 9. G composed of f is g of f of x, which is g of 2x minus 1, which is 3 times 2x minus 1 squared, which is 3 times, and the shortcut works for this too, just like it works for any squaring one. Doesn't matter what's in first or last. Square the first term, 2x, take 2x squared, I get 4x squared. Multiply the 2, 2x times negative 1 is negative 2x, double it, minus 4x, square the last term, plus 1. If you FOIL it out, combine up the like terms in the middle, you'll get the same thing. And then multiply everything times 3, 12x squared minus 12x plus 3. And the last one, h composed of f of 3 is h of f of 3. And f of 3 is 2 times 3 minus 1, which is 5. So this is really h of 5, which is negative 5 plus 5, which is 0, zip, zilch, nada. The big donut. Woo. Or if you don't like donuts, the big bagel. Either one's good for breakfast. Put a little smear on it. Any questions?
What is F over 304, 7 over 48?
F over,
What about 48?
come on,
Yep.
7 over 48. Question.
If it was in my,
What?
never mind.
Because h is negative x plus 5.
Yeah.
So I put in 5 for x.
I thought the 5 would be positive because for some reason I got a negative 5, and then the negative 5 in the x for h of x would equal 5, so I got 10 instead of 0.
No, it should be, because first you put 5 into f. 2 times 5 gives you, no, you put 3 in here. Sorry, you put 3 in here. 2 times 3 is 6. 6 minus 1 gives you positive 5. And then you're putting in positive 5 into here.
That's right.
Okay? Any other questions? Awesome. Relatively short.